March 21, 1984. The Sea of Japan. It is 2200 hours. Pitch black. The water temperature is near freezing. A winter storm is raging, with waves cresting at 8 feet. Captain David Rogers is standing on the bridge of the USS Kitty Hawk. He is commanding an 80,000-ton American supercarrier, a floating city of jet fuel and high explosives. He is conducting night flight operations. The flight deck is dim to preserve pilot night vision, but his navigation lights are burning. Yet, in the driving rain and the chaotic spray of the storm, the Soviet captain out there is blind to them. Suddenly, the ship shudders violently. It isn't a subtle vibration. It feels like the entire vessel has driven over a concrete wall. The 1,000-foot steel deck jumps beneath his feet. Captain Rogers grabs the railing. His first thought is that they have run aground. But the chart says the water here is 600 feet deep. There are no reefs, there are no shoals. Rogers looks out into the darkness of the starboard side. He doesn't see a rock. He doesn't see a whale. He sees the black, metallic silhouette of a Soviet nuclear attack submarine conning tower tumbling in his wake. He has just run over a Soviet nuclear attack submarine. This is the story of the Kitty Hawk collision. In the popular imagination, the nuclear submarine is the apex predator of the ocean. We are taught that it is a silent, invisible killer, that it can hear a heartbeat from 50 miles away. We are taught that the surface ship is the prey and the submarine is the hunter. But on this night, the predator was effectively deaf and intermittently blind. Therefore, instead of sinking the carrier, the Soviet submarine K-314 was turned into roadkill. This likely wasn't just a navigational accident. It was the kinetic termination of a spy mission gone wrong. It was a probable failure of physics, a failure of acoustics, and a failure of nerve. And while it humiliated the Soviet Union, it handed the United States what many believe to be one of the greatest intelligence trophies of the Cold War. A literal piece of the enemy delivered directly into the hull of an American ship. To understand why a Soviet captain would park his submarine in the fast lane of an American aircraft carrier, you have to look at the calendar. The year is 1984. We often look back at the Cold War as a long, stable freeze, but in 1983 and 1984, the ice was cracking. The world was arguably closer to a nuclear exchange than at any point since the Cuban Missile Crisis. The Soviet leadership in Moscow was old, dying, and paranoid. Intelligence reports from the era suggest they were convinced that the United States was preparing for a first strike.
I would rather see my little girls die now, still believing in God, than have them grow up under communism and one day die no longer believing in God.
Just 6 months earlier, in September 1983, a Soviet Su-15 interceptor had shot down Korean Airlines Flight 007 over Sakhalin Island. 269 civilians were dead.
The United States reacts with revulsion to this attack. Loss of life appears to be heavy. We can see no excuse whatsoever for this appalling act.
The Soviets didn't apologize. They claimed the airliner was a spy plane. They claimed it was a probe for a nuclear attack. Then came Able Archer 83, a NATO exercise that simulated a nuclear launch code release. The Kremlin panicked. They put their nuclear forces on high alert. They loaded bombers. They believed the end was coming. Therefore, the strategic environment in the Pacific was toxic. When the U.S. Navy announced Team Spirit 84 in the Sea of Japan, the Soviets didn't see a training drill. They saw an invasion force massing on their border. The USS Kitty Hawk wasn't just a ship to them. To the Soviet Pacific Fleet, she was a high-value unit, a nuclear delivery system parked on their doorstep capable of launching strikes against Vladivostok. Therefore, the order went out from fleet headquarters: do not let them out of your sight. Team spirit was massive. It involved 200,000 troops. It was designed to show the world that the U.S. could rapidly reinforce South Korea. The centerpiece was Battle Group Bravo, led by the Kitty Hawk. For the Soviet Navy, this was a threat, but it was also an opportunity. If they could shadow the carrier, they could record its electronic emissions, they could map its radar frequencies, they could learn its tactics. So, they dispatched a shadow group. This group included surface ships, intelligence trawlers, and one nuclear-powered attack submarine, the K-314. Her captain was Vladimir Evsienko. Evsienko was a competent officer. He knew his boat, he knew the Sea of Japan, but he was operating under a doctrine that demanded aggression. In the Soviet Navy, you didn't get promoted for being safe, you got promoted for being bold. His orders were specific: mark the carrier. This meant he had to maintain a continuous firing solution. If the Cold War turned hot, his job was to put a torpedo into the Kitty Hawk's rudder before she could launch a single plane. To do that, he couldn't sit back at 50 miles. He had to get close, knife-fighting range. But the Americans knew he was there. For a week, it was a brutal game of cat and mouse. The carrier's escorts, destroyers and frigates harassed the K-314. They pinged him with active sonar. P-3 Orion aircraft dropped sonobuoys on his head. They simulated killing him 15 times. For a submarine captain, this is humiliating. It is stressful. Therefore, Evsienko likely became aggressive. He stopped hiding. He started chasing. He seemingly decided that he wouldn't just trail the carrier, he would get underneath it. To understand the collision, you have to understand the machines. In the blue corner, the USS Kitty Hawk, CV-63. She is a dinosaur compared to the modern nuclear carriers. She doesn't run on atoms, she runs on oil. Deep inside her hull, she carries 4 Westinghouse-geared steam turbines. These are massive, roaring beasts that generate 280,000 shaft horsepower. When the captain orders flank speed, massive boilers inject superheated steam into these turbines, spinning 4 propeller shafts at incredible RPM. This creates a massive acoustic footprint. At high speed, the Kitty Hawk is deafening. To a submarine, it sounds like a freight train. In the red corner, the K-314, NATO code name Victor 1. When the Soviets built the Victor, they abandoned the clunky ship-like hulls of the 1960s. They adopted the teardrop shape, a hull optimized for underwater hydrodynamics. It was fast, it was agile, it was nuclear-powered. But the Soviet engineers made a critical design choice that would come back to haunt Captain Evsienko. They gave the boat a single screw. Redundancy failure. American carriers have 4 shafts. If one fails, they have 3 left. The Victor 1 has 1 shaft, 1 propeller. If that single point of failure is compromised, the submarine is dead in the water. Furthermore, early Soviet propellers were 4-bladed and poorly skewed, which meant they were prone to cavitation, creating noise bubbles at relatively low speeds. Therefore, the K-314 had a speed limit. If Captain Evsienko went faster than 15 knots, his propeller would likely start to sing. He would light up on American sonar like a Christmas tree. So he had to move slowly. But the Kitty Hawk was moving fast. This created the tactical nightmare known as sprint and drift. To keep up with the carrier, Evsienko had to sprint. He had to push his reactor to 80% and drive the boat at 25 knots. But when a submarine moves that fast, the water rushing over its own nose creates flow noise. Imagine trying to listen to a whisper while sticking your head out of a moving car window on the highway. The wind noise deafens you. Therefore, every time the K-314 sprinted to catch up to the Americans, it went effectively deaf. Evsienko was trapped in a cycle: sprint, deaf, catch up, slow down, clear, listen, realize the carrier has turned, sprint again, death. He was playing a game of tag with an 80,000-ton monster, and he was doing it blindfolded half the time. And he had a second blind spot, the baffles. Because his propeller was churning at the back, he couldn't hear anything behind him. He likely assumed the carrier was in front of him, running away. But thanks to the storm, the carrier had changed course. It wasn't running away, it was sneaking up on his tail. And on March 21st, the ocean decided to turn the lights out. March 21st, 2200 hours. The weather in the Sea of Japan turned violent. Sea state 4. The waves were 8 feet high and confused. The wind was gusting to 30 knots. For a surface ship like the Kitty Hawk, this is uncomfortable. The massive flight deck pitches and rolls. Launching aircraft becomes a dangerous dance of timing and throttle. To launch jets into this wind, Captain Rogers needs wind over deck. The carrier is punching through the heavy seas at 18 knots, but combined with the headwind, it is generating over 30 knots of airflow across the deck. It is moving fast, erratic, and loud. But for a submarine, this weather is catastrophic. It isn't about stability. At 60 meters deep, the K314 is rock steady. It's about acoustics. Sonar relies on listening for tonals, specific frequencies made by enemy machinery. You're looking for the 60-cycle hum of an American generator or the 120 RPM thrum of a propeller. But millions of tons of crashing water creates a broadband noise floor. It sounds like static on an old TV cranked to maximum volume. The storm effectively turned the ocean into a white noise machine. Every time a wave breaks on the surface, it sends a cascade of bubbles down into the water column. These bubbles absorb sound. They scatter sonar pings. Therefore, the Kitty Hawk is out there, churning through the waves, but its specific sound signature is being buried under the roar of the sea. And the geography makes it worse. The Sea of Japan isn't the deep Atlantic, it's a marginal sea. It's relatively shallow near the continental shelf where they were operating. In deep water, sound travels in clean lines called convergence zones. You can predict where the sound will go. But in shallow water, sound hits the bottom. Bottom bounce reverberation. If the seabed is mud, it absorbs sound. If it's rock, it reflects it. In the Sea of Japan, the bottom is jagged and rocky. The sound of the carrier's engines hits the bottom, bounces up to the surface, hits a wave, and bounces back down. It creates a hall of mirrors. A single ship can sound like 5 ships, or it can sound like nothing at all. The sonar operators on the K314 are staring at their screens. They are likely seeing ghosts. They see a contact bearing 090, then it vanishes, then it appears at 270. Is it the carrier? Is it a fishing boat? Is it a reflection of their own noise? They are blind.
By 2200 hours, Captain Evsienko must have realized the truth. He had lost the Kitty Hawk. This is a potential career-ending failure. His entire job is to hold contact. Deceptive lighting protocols. U.S. carriers often engage in masking. By reconfiguring their mast lights, the Kitty Hawk can visually mimic the silhouette of a much smaller ship, like a guided missile cruiser or a fishing trawler. If Evsienko saw a light in the storm, he likely misidentified the threat. Blinded by the storm and potentially fooled by the lights, he was desperate. He needed a fix. He tried to reacquire the target. He ordered a sprint. He pushed the reactor. The K314 accelerated. He likely hoped to race ahead, get in front of the storm, and find the carrier again. But remember the paradox. By sprinting, he made his own boat deaf. And he created a second blind spot, the baffles. Because his propeller was churning at high speed, he couldn't hear anything behind him. He assumed the carrier was still in front of him, running away. He was wrong. The Kitty Hawk had turned. She had turned behind him to launch aircraft. Captain Evsienko was now sprinting away from the target, while the target was sneaking up on his tail. He sprinted for an hour. Nothing. He slowed down to listen. Nothing. Just the roar of the storm. He was desperate. He needed a fix. If he couldn't hear the carrier, he had to see it. Therefore, he made the decision that would seal his fate. He ordered the boat up, periscope depth, 10 meters below the surface. His plan was likely simple. Raise the ESM mast. The carrier's aircraft use radar. The carrier communicates with radios. The ESM mast is like a radio antenna. It detects those invisible signals. It would be like seeing a lighthouse in the dark. But he didn't realize that by going to periscope depth, he was entering the kill zone. At 60 meters, he was safe. The carrier draws 11 meters of water. He could pass right under it. But at 10 meters, he was putting his steel sail directly in line with the carrier's steel keel. 22:05. The K-314 leveled off just beneath the waves. The boat rocked violently in the storm. Captain Evsienko raised the periscope. He gripped the handles and spun it around, looking for lights, looking for the distant glow of a city at sea. He expected the carrier to be 20 miles away, but when he looked through the lens, he didn't see the horizon. He saw a wall. The Kitty Hawk was dim, but her navigation lights were on. However, through the rain-streaked periscope, amidst the confused seas, Evsienko saw only a massive gray cliff of steel. It wasn't miles away, it was roughly 4 kilometers away. And it was getting bigger every second. The carrier was moving at nearly 18 knots directly at him. That is 9 meters per second. Evsienko froze. He was looking at 80,000 tons of American sovereign territory bearing down on him like a freight train. He screamed for a crash dive. Flood negative, down angle on the bow, all ahead flank. But a 4,000-ton submarine doesn't turn like a sports car. It has inertia. It takes time to flood the tanks. It takes time to point the nose down. And he didn't have time. Physics was about to take over. 22:07 hours. The collision geometry was a worst-case scenario. Usually, when ships collide, it is a glancing blow, or a T-bone. But this was different. This was a run-over. The K-314 was directly in the path of the Kitty Hawk. The submarine was limping forward. The carrier was charging up from behind at 30 knots. It wasn't a fight. It was a monster truck running over a sedan. Captain Evsienko saw the mountain of steel filling his periscope and screamed for emergency deep. He ordered the ballast tanks to blow. He ordered the planes to full dive. He wasn't trying to dodge left or right. He was trying to get under the keel. The Kitty Hawk draws about 11 meters of water, 36 feet. The K-314 was at 10 meters. He needed to dive just 5 more meters to clear the hull, just 15 feet. It sounds easy, but a 4,000-ton submarine has vertical inertia. You cannot just point the nose down and drop like a stone. You have to overcome the buoyancy of the air inside the hull. And as the submarine struggled to dive, physics intervened with a force that Captain Evsienko likely couldn't fight. Bernoulli's Principle. This is the same law of physics that makes airplanes fly. When a fluid moves fast over a surface, its pressure drops. As the massive 80,000-ton hull of the Kitty Hawk rushed over the top of the submarine, it displaced thousands of tons of water. This created a zone of intensely low pressure between the carrier's keel and the submarine's sail. Hydrodynamic interaction effect, specifically the suction force. The water velocity between the two hulls accelerated rapidly. According to Bernoulli, as velocity increases, pressure decreases. This created a vacuum effect. The ocean literally sucked the K-314 upwards towards the carrier. The harder Evsienko tried to dive, the harder the physics pulled him up. Therefore, the submarine was trapped. It was like being caught in a tractor beam. The K-314 shuddered as it was lifted out of its dive. The crew could hear the roar of the carrier's screws getting louder. And then, impact. It wasn't a bang. It was a grinding, screaming tear that lasted for seconds.
The Kitty Hawk's bow, specifically the forward fuel tanks, surged over the K-314's stern, crushing the starboard stabilizer and shearing off the propeller completely.
Think of a semi-truck hitting a fire hydrant at 20 miles per hour. The submarine didn't stop the carrier. It bounced. The impact imparted a violent rotational force. The K-314 rolled 90 degrees to starboard. Inside the control room, men were thrown from their stations. Books, charts, and coffee cups flew across the room. Captain Evsienko was thrown against the periscope stand. His first thought was terror. The sail is gone. If the sail had been sheared off, the pressure hull would be breached. The Pacific Ocean would rush in. They would sink in seconds. But the Soviet engineers had built the Victor-class tough. The hull held. Therefore, they survived the first hit. But as the submarine tumbled along the bottom of the carrier's hull, like a rag doll under a car, the laws of probability delivered a second, more specific blow. The roundhouse kick. As the submarine rolled, its stern swung upward. The K-314 has a single, massive bronze propeller. It's 4 meters across, and it was still spinning at high speed. It slashed upward into the bottom of the Kitty Hawk. It was metal on metal, bronze versus steel. The propeller shattered. One of the massive blades sheared off completely. It punched through the carrier's outer plating and embedded itself deep inside the American ship's #1 fuel oil tank. On the submarine, the effect was catastrophic. The K-314 was alive, but she was crippled. She had no propulsion. She began to drift, silent and helpless in the turbulent wake of the enemy. According to official reports, the Kitty Hawk bled thousands of gallons of JP-5 jet fuel into the sea. JP-5 flashpoint. Naval fuel is engineered with a high flashpoint to prevent fires during combat. Even with sparks flying, the ocean likely wouldn't burn. The fuel was safe, and the nuclear reactors on both vessels reportedly held. But as the sun rose, the K-314 faced total exposure. Dead in the water with a shattered screw, the apex predator was reduced to a helpless target for U.S. Navy photographers. A Soviet tug eventually dragged the humiliated sub home. The Americans thought the victory was symbolic. They were wrong. The collision had inadvertently delivered a massive intelligence payload directly into the American hull. In the Yokosuka dry dock, engineers found the Holy Grail embedded in the carrier's #1 fuel tank, a fragment of the Soviet propeller. Alloy reverse engineering. By analyzing the manganese-bronze crystal structure, U.S. metallurgists could likely calculate the exact singing speed of the Victor class, updating the acoustic target library for American torpedoes. Simultaneously, divers harvested cluster guard anechoic tiles from the hull. Acoustic void analysis. By measuring the internal air channels in the rubber, the Navy could mathematically determine exactly which sonar frequencies the Soviets were trying to hide from. The collision didn't just stop the spy, it stripped her naked. The crew reportedly painted a red kill mark on the bridge, but it was quietly removed soon after. The K-314 met a grim end first, suffering a reactor meltdown years later. The Kitty Hawk survived the Cold War, but she could not survive time. Decommissioned in 2009, she was eventually towed to a Texas scrapyard in 2022. There were no more enemies to chase, just recycling contracts. The collision of March 1984 proves one final rule of engineering. You can build the fastest submarine in the world. You can wrap it in high-tech rubber.
You can give it a nuclear heart that can power a city. But if you cannot see where you are going, physics will eventually find you.